All right, lesson 8.4, relationships among the trig functions. Now this video is more just going to give you background between relationships, and then we'll practice a lot in class with what you're actually supposed to do with these. Oop, what's going on here? Okay, write each function in terms of sine and or cosine. So a lot of this should be a review. We know the tangent function is sine divided by cosine. We know the cosecant function is the reciprocal of the sine function. Secant is the reciprocal of cosine. And cotan, we can write it in two different ways. We can write it as the reciprocal of the tangent function. And since tangent is written in terms of sine and cosine, we could also write it as cosine divided by sine. So what we're going to be doing through the next two lessons is simplifying trig expressions, improving trig identities. So depending on which relationship you'll need for cotangent, that'll all be determined as you practice more and see different types of problems. Okay, so to simplify this, the first rule of thumb is that you want to rewrite any function in terms of sine or cosine. So if I look at this, sine x can't be simplified any further, but I know that cosecant is the reciprocal of the sine function. So I'm going to replace cosecant with 1 over sine x. Now look what happens. Sine divided by sine is 1. So this expression simply becomes 1. That's it. Okay, negative relationships among the functions. Again, things that we've studied already. So here's theta. Okay, we know that theta starts at the positive x-axis, and if theta is positive, we rotate in the counterclockwise direction. So if I take this angle and I rotate it in the clockwise direction, therefore creating negative theta, what's the sine function? Well, in the fourth quadrant, we know the sine function's negative. So this would be equivalent to the opposite of the sine of theta. For the cosine function, if I take my angle and I rotate it in the clockwise direction and I get negative theta, well, in the fourth quadrant, cosine is positive. So this would be equivalent to cosine of theta. Likewise, tangent, if I rotate in the clockwise direction, tangent is also negative in the fourth quadrant. So this would be equivalent to the opposite of the tan function. Now, I know nobody really liked it, but we studied these when we looked at inverse sine, inverse cosine, and inverse tangent functions. We did study these behaviors in the relationship that in the fourth quadrant, sine and tangent are just opposite of what their exact values are. So the properties of the function and their reciprocals hold true as well. So for cosecant, which is a reciprocal of sine, this would be the opposite of the cosecant of theta. Secant's the reciprocal of cosine, so this would just be equal to the secant of theta. Cotangent would be the opposite of the cotan of theta. And it's all about the quadrants, okay? When we rotate in the clockwise direction, it's just the opposite of what the exact value would be. Okay, so now to simplify, sine of negative theta is equal to the opposite of the sine of theta. Secant is the reciprocal of my cosine function, so I'll write that as 1 over cosine. And now tangent, I'm going to do the one that isn't helpful first. I'm going to rewrite cotan as 1 over the tangent. It's not incorrect, it just doesn't do anything as far as simplifying is concerned. And like I started, the rule of thumb, you really want to rewrite in terms of sine and cosine. So if I take cotangent and now I write it in terms of sine and cosine as cosine divided by sine, now what do I see that cancels? Cosine divided by cosine is 1, negative sine divided by sine, so that entire expression just simplifies to negative 1. Okay, so let's come back to the unit circle. We know the unit circle is a circle with a radius of 1 and a center of 0, 0. From the unit circle, we were able to determine our exact values for sine, cosine, and tangent of our pi over 3, pi over 4, pi over 6, on our axes, so we spent a lot of time doing those. So recall that cosine was x over radius and sine was y over radius. So now if my radius is equal to 1, because I'm on the unit circle, then x is equal to cosine of theta and y is equal to sine of theta. We've studied this, right? Any point on the unit circle, the x coordinate's always the cosine function, the y coordinate's always the sine function. So now if I look at this triangle as the right triangle that it is, the Pythagorean identity, think about that, the Pythagorean theorem, x squared plus y squared equals r squared. Now when I look at the pieces, x is my cosine function, cosine squared, y is my sine function, and I know that my radius is 1. So fixing this up, because this is how you'll see it in your textbooks, cosine squared x plus sine squared x equals 1. This is one of your 3 Pythagorean identities. You will use it over and over again. You have to become very familiar with it, and it's very recognizable. Okay, so that's equation number 1. Now, let's think about properties of equations. So I skipped over this here. An identity is a trigonometric relationship that is always true. So once we talk about the identities, you can use them at any time that you need, when you're solving problems, simplifying problems. Okay, so just like the reciprocal functions, we know them, we use them, we don't have to prove them every single time we want to use one in a problem. So now, oops, I had to hit eraser. Think about taking this Pythagorean identity, and I'm going to divide every term by cosine squared of x. So when I do that, anything divided by itself is 1. Sine squared divided by cosine squared is tangent squared of x. 1 divided by cosine squared of x is secant squared of x. So there's Pythagorean identity number 2. Let me erase that and put a 1. So here's my first. Okay, so now let me go back to my first equation, cosine squared plus sine squared x equals 1. And now I'm going to take each term and I'm going to divide it by the sine squared of x. As long as I maintain and do the same thing to every part of the equation, mathematically, it's fine. Okay, so what's my third Pythagorean identity? Cosine squared divided by sine squared is cotangent squared of x. Anything divided by itself is 1. And the reciprocal of sine squared is cosecant squared of x. So you will be expected to recognize these and use them in any given problem. Okay, and that's easy for me to say here. For you, it's just all about practice. So you're going to be practicing these problems and using these functions. Okay. So now cofunction relationships among functions. Okay, lots of functions there. So I just focused on the first quadrant of the unit circle. Okay, so here I am at 30 degrees. Cosine of 30 degrees is square root of 3 over 2. Sine of 30 degrees is a half, right? We just talked about the x and the y coordinate represent the cosine and the sine of a given angle measure. Okay, we'll check out this relationship when I get to 60 degrees. Now the cosine of 60 degrees is a half, and the sine of 60 degrees is square root of 3 over 2. So notice that they're the same values, but they change cosine or sine when my angle measure is different. Now, not only that, look at the relationship of these angle measures. They're complements of each other. Remember that complementary angles are 2 angles that add up to 90 degrees. So the sine of theta is actually equal to the cosine of its complement. So the cosine of 90 degrees minus theta. Likewise, the cosine of theta is equal to the sine of its complement. So the sine of 90 degrees minus theta. Now, if we were working in radians, the exact same property exists. It would be the cosine of pi over 2 minus theta, or the sine of pi over 2 minus theta for the cofunction of cosine. This was actually a quiz question last chapter where you had to answer this, and it asked you about this relationship. Okay. Cofunctions are complementary angles. Okay, so important relationship there. Okay, so 1 plus tangent squared of 90 degrees minus theta. Okay, now we'll talk about this one in class as far as where this answer can go, but I want you to sort of recognize this form. You have 1 plus tan squared of something. Okay, I'm just going to call that something. I'm going to replace that 90 degrees minus theta with one variable. Okay, so now something that we're going to have to work on, whenever you see a squared trig function and a 1, you have to think about the identities. So if I go back to my Pythagorean identities, 1 plus tangent squared is always equal to secant squared of x. So 1 plus tangent squared of x is equal to the secant squared of x. Okay, now remember we replaced x with 90 minus theta to start. Okay, now what I would like you to try and think of for homework, what is the cofunction of secant? So the secant of theta would be equal to what function, what cofunction? Okay, so try and think about that. I mean, don't hesitate to look in your textbook, maybe look it up, okay, Google it online, something like that. But for your homework, try and answer that question for me. And we'll talk about it in class tomorrow.